Hello and welcome back to my channel. Today I'm going to do some neural network classifier on the PIMA diabetes dataset. A dataset can be obtained in this link, kaggle.com, and let's get started. First I'm going to load the special library for this. The Torch library, the NumPy library, and the Pandas library. Going to load as well the necessary pre-processing classes. As well as the class for dividing the data from training set, validation test, and test set. I'm going to also load the classes for the dataset in Pytorch and the DataLoader. I think this was it. Okay, DataLoader. Okay, now let's load the dataset. Okay, as you can see, I just wrote it here, PIMA diabetes CSP, so that I will know what is the name of the downloaded file. So diabetes has this, so it has about these features: pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, and this one, and as well as age. And the last column is the outcome. Now I'm going to separate this data set into these features. I will call it X, and the targets I will call it Y. Okay, now it's already separated. I'm going to prepare the X data into training, separate them first. Okay, so let's separate the data, the X data, into training, test, and validation. Okay, in this line of code, I'm going to split this into two. So the test size is 40 or 40%, and the training size is the 60%. Now in this case, I'm just going to split it first into the training and a group. Then I will go to split it again into the test and the validation set. So here it goes. For train index, group index in SS.split. So I'm going to split X and Y. So x train x group is equal to x train index and x group index, as well as y train y group to y train index y group index. Okay, next is I'm going to split again this group into two. This time the test size is equal to 0.5, or it will be a 50-50 split. For test index, validation index in ss.split x group y group. Okay, this is the x group and the y group. I'm going to split it again. X test x valid lead is equal to x group test index x group valid index. Y test y valid is equal to y group test index and y group valid index. Okay, now we already have the x train, x test, and the x validation, and we have the y train, y test, and y validation. Now let's as standardize features or the x values. Okay, so SC standard scalar. Okay, then x train is equal to sc.fit transform. We fit first in order that we get the mean and the standard deviation, transform and apply it to x train, and we're going to do the same, but this time in x test we just need to transform this because we already know the mean and the standard deviation. X valid is equal to sc.transform x valid. Okay, next we're going to convert them into tensors. Okay, so x train x test x valid is equal to map function of Python torch to tensor, and we're going to do x train x test x valid. Okay, we're going to do the same. Train y test y valid equals to map torch to tensor, the group y train y valid and y test and y valid. Afterwards, make the tensors d-type as float for x values only. So in training the dataset, the data it needs to be in the float. So here we go. X train is equal to x train dot float. X test equals to x test dot float. X valid is equal to x valid dot float. Okay. After this, we're going to prepare. Okay, let's just run this first. Okay, no error. Then prepare to load the X-train dataset by dividing it into small chunks. Okay, first we're going to define a wrapper from the Pytorch dataset. So define a class. We're going to use this so that we can load the data using the Pytorch DataLoader. Clutch DDS datasets. It's an object of type dataset. I'm going to initialize this, define init self, and we need the, the x value and the y value, which is the features and the labels. So self.x equals to x, self.y is equal to y. Okay. Next, we're going to define the get item. Get item. Okay. Self and index. Okay. Return self x index and self.y index. Okay. Next, we're going to define length self, and it will return the length of any self.x, okay, or self.y. Okay. Then we're going to make this as a wrapper. We're going to wrap the data prior to data loading. So my data is equal to DDS, and input is the X train and the Y train. Okay. Then train loader is equal to data loader. Dataset is equal to my data, and what do you call this? Okay, let me see. I forgot about the other shuffle sampler batch size. That's it. So every batch there is how many rows, or let's say my batch size will be around 32. Okay, that's about it. Okay, now our data set is already ready for processing, testing, and validating. Now we're going to create a neural network architecture. I call it architecture because it gives you how many, what is the length and the width of the neural network. So it's just my personal name. So let's see, class feed forward. Yes, because this is just a multi-level perceptron or feed forward neural network. So it is type an object type torch nn that module. Okay, then we need to initialize them. Define init self, and we get to indicate number of inputs, number of outputs, and the hidden size. Okay, next is we're going to next we're going to super it feed forward self init. Okay, so then I'm going to put it here, self.inputs is equal to n inputs, self.outputs is equal to n outputs. Then the self.hidden, or the size of the neural net, number of neurons in itself. So that is the number of neurons that should be. Sorry about that. So it's the number of neurons that you'll be getting on. Next, we're going to define the layers. Okay, so self that fully connected layer number one is equal to torch and then linear. Okay, then it has the inputs, self that inputs self and self that hidden. Okay, next self that fc2 fully connected to torch that nn that linear, self that hidden, and its output is also hidden, the number. Then I'm going to continue making this up to 5, perhaps 2 3 4 5. Okay, 1 2 3 4 5, and the last one is self that outputs. Okay, define the layers. Then let's define the activation function. My activation function for this one is relu torch that nn that relu. Okay, okay, next let's define first the initialization of first init waits self. Okay, so let's initialize the wait. So torch that nn that init that timing normal self that fc1 dot waits, and then I'm going to copy this, initialize all the waits. Okay, 1 2 3 4 5 6. Next I'm going to initialize the weights here. So let's run this. Self that init weights. Okay, next we define the forward pass or the forward propagation self and the features or the inputs. Okay, forward propagation, we're going to use first the output. The output of this one will go to the first self that fc1. Okay, self that fc1 features. Okay, next the output self that fc2 output. Okay, I'm going to do this up to 3 4 5, and then every layers I'm going to put the activation function. Output is equal to self dot relu output, and copy this, control V, control V, okay, then return the output, return output. Okay, that's it. So this is a neural network architecture. Okay, then we're going to define create a network object. Okay, I'll make it model. It's a feed forward, then I'm going to define them as n inputs is equal to x train dot shape 0, no, shape 1. Okay, that's how many columns there is in x train, or that is how many features there is. Okay, and outputs is equal to 2 because it is either 1 or 0. And what's next? Hidden size. Going to make it 100 neurons per layer. Okay, next I'm going to create a criteria loss function. Criteria criterion is equal to and torch.nn dot. My criterion will be cross entropy loss. Where is it? Let's find the cross entropy loss. Okay, this one. And let's check again what are some parameters that I need to put here. I need to size, average, reduce, reduction, cost to mean. Okay, let's put it here. Reduction is equal to mean. So it will average on the batch sizes. Okay. Next, I create an optimization or gradient. Okay. So optimizer is equal to torch.optim and tabulate. I need about SGD. Okay. Okay. And the params that I'm going to pass this is the model parameters. Model parameters. Okay. And learning rate is equal to 0.001 0.01. That will be fine. And I'm going to make put some momentum, which is equal to 0.9. Okay, that's what it. Let's see if there's still an okay, there's a problem here. Okay, so up that F6. So we don't have any F6. F1, 2, 3, 4, 5, 6. Okay, problem here. Sorry. Click again and run this again. Okay, no more problem. Now we are going to train the network. Train the network. Okay, so I'm going to provide the number of epochs or training cycle. So I'll say it's for initially. Let's put it at 10, and the pay. And we're going to make a list. Validation accuracy. Valid accuracy. It's a list containing the initial of 0. Okay, then I'm going to put again the patience. Initialize the patience to 0. Okay, I need this validate epochs is the number of cycles. Okay, valid accuracy is a list which has initial value of 0. So I need this so that there will be an early stopping on this one. So I'm going to implement early stopping, and the patience is equal to 0. Okay, based on the accuracy, if it's degrading or getting better, so the number of the patients will go up, and if it reach a certain amount of patients, then it will stop training. Okay, so let's start for epoch in range epochs. Okay, for features targets in train loader, that is already one. Okay, so let's start output. Okay, forward propagation. Output is equal to model that forward. Okay, and my input are the features. Okay, next is calculate the loss. Okay, now let's calculate the loss. Loss is equal to criterion. So we're going to check if we're going to compare the features, no, the output to the targets. Okay, then we initialize the gradient to 0. Okay, so that we have 0 gradient again. So optimizer 0 grad. Okay, next we do back propagation. Loss that backward. Okay. Next, we update the weights. Okay. So optimizer. That's step. That is the function. I'm going to update the weights. Okay. Now for each epoch, so this will be run on how many batch are there in each epoch. I'm going to stop the training. Okay. So model dot eval, going to stop the training, and let's compute for the accuracy. Okay. Predict is equal to, first we're going to, sorry, that's not the one. We're going to check the output, the accuracy of the output, training output. So I'll just put it here as letter C is equal to torch that argmax. Okay. The output data dimension equals to 1. So across each rows, or I'm going to get the maximum value. Which column has the maximum value? Of course, the output has only 2 columns. Okay, because the output of this network architecture outputs is equal to 2 here. Okay. Next, I'm going to create the train accuracy. Compare it. So we have here this is equal to C is equal to the output is equal to the targets. Okay, the output of this one is equal to the targets, and going to get the sum of them and then the item. Okay, if we put it the item, so it means that the number value, because it's already been averaged. Okay, and then we divide it by the targets that shape 0, or the length of this target. Okay, then let's try to print the accuracy. Print, this is just for testing purposes. Let's see, train accuracy. Okay, then we resume the training of the model. Let's see. Okay, there's a long pairing here, there. Run again. Okay, so it's working fine. So it's below, it is there. Okay, it's good. Now we continue with, after we do this train accuracy, we're going to evaluate it. Okay, evaluate it. So I'm going to predict using use the model to predict validation set. Okay, predict is equal to model that forward xval. Is it xval or xvalid? I think it's xvalid. Here, xvalid. Okay, so xvalid, that's it. Then we're going to compare it again. C1, first we're going to convert this torch argmax predict data dim is equal to 1, then valid accuracy is equal to C1 is equal to targets, just like this in on the top. That sum, that item over, we're going to compare them to targets, not targets. It should be y valid data, because y valid at shape 0. Okay, then afterwards we're going to print them. Print. In this print, I'm going to include already the epoch. Okay, over. Okay, and the loss. Print the loss. train accuracy, okay, train accuracy, and the validation accuracy. Okay, format. So we have here the epochs, loss, train accuracy, and the valid accuracy. Okay, let's try. Okay, here. So I need to delete this one. No need to print this. Run again. So the validation accuracy is increasing. That's good. Training is still the same. The loss is decreasing. Okay. It's not yet done. So next, I'm going to provide the, okay, I'm just going to put it here to training again. Then I'm going to provide the, what you call this, early stopping mechanism. Okay, if, so we have here the valid accuracy. Now I'm going to change the name of this one. So let's say valid list. Okay, if valid list, the latest valid list is greater than or less than the previous latest valid list. Patience, okay, if it's less than, so we need to increase the patience equal to 1. Okay, if patience is greater than, if it reach number of 2, it means that this is degrading. Okay, the validation accuracy is degrading. If it reaches number 2, so we need to break the loop. Okay, if valid list -1 is greater than valid list, okay, -2, so patience minus equal to 1. If patience, so we need to subtract the patience. If patience is less than 0, patience, so we need to initialize it back again to 0. Okay, let's see. Alright, list index is out of range. Okay, it's out of range, so I need to include again another 0 here. Okay, so now epoch 9 and 10, so it's already finished validating. No, it's not yet because we only have 10 epochs. So let's say we put here 200 epochs. Okay, does it reach, did it reach the whole 200? No. Yes, it does. Okay, so maybe there's something wrong here. Let's try it maybe 300. Shouldn't be able to last that long. Okay, let's try again. validation accuracy is still increasing. Hmm. Let's see what's wrong with this. So I'm already put the early stop the training and start again the training. This one we complete the validation accuracy. Okay, use the model to predict it and start again. Okay, there's nothing wrong here. Features, targets, early stopping, valid list is -1. Okay, so I did not update the validation list. So I need to update first the validation list. Append. Okay, I need to append this new valid accuracy. That's what happened. Okay, so if I update that, so this will update. So let's try to reduce the learning rate 0.001, 0.01. Okay, and what else can I do here? So I've already updated the valid accuracy. Okay, if patience plus equals to 1 is greater than 2, maybe I missed something. Maybe I missed something because it did not stop early on. Okay, maybe I missed something. But here, the accuracy is still increasing. It seems that the validation accuracy is not. Move to the forward, X valid, torch now. Okay, let's try this. I'm going to restart this again. Restart and run all. Let's see what will happen. Yeah, so that's what happens. Okay, so now it reaches here. So it's already working now. Let's see now. Let's check if the output is really a two columns output. So you see there's two columns in the output and each output has this amount. Okay, now let's try the accuracy of this one on the test data. Okay, in order to do that, we're going to make with torch.nograd. Okay, so it means that it's, it's in the evaluation mode. Okay, predict is equal to model dot forward, and we're going to use the xtest data. Okay, and then let's do this. Get the argmax function, torch.argmax predict data dim is equal to 1. Okay, then compared it with accuracy, test accuracy is equal to test accuracy is equal to C is equal to x y test. Okay, that sum, that item. Okay, divided by y test at shape 0. Okay, then let's print it out. Testing accuracy is okay, format test accuracy. Okay, so testing accuracy is 72%. Okay, so that is how we make Pytorch neural network using PIMA diabetes dataset. So can we still increase the accuracy of this one? So let us say, okay, maybe I'll make the patients 3. Okay, and save it, and let's restart and run all. The accuracy increases. Actually, this is random, so that's why you need at least 3 neural network in order to have an average value of the accuracy. Okay, so that's all for now. Hope you like this video. If you want more like these videos, please click the subscribe button. Okay, thank you for now. Bye. Thank you for watching.